Welcome to Study Loop.
Okay, so in this problem we have to explain why the steam injection increases power output and the efficiency of gas turbines. So let's remember that the Brayton cycle, or the gas turbine that we are dealing, uh, operates by the following process here. So let's see. We have the air enter the compressor, then this air suffers a combustion and he leaves here already heated in the turbine. So this is the turbine, this is the compressor, and this is where happens the combustion. So we need to explain why the steam injection increases power output. What we must know, first of all, is that the steam can be obtained by utilizing the hot exhausted gas. So we reutilize this gas here and throw it in the compressor again. So this steam injection, as we're gonna call, increases the mass flow rate through the turbine because the air passes through the entire engine again, and increases the mass flow, and thus the power output. So since the power in the turbine is greater, the power output is greater. And because of that, the thermal efficiency, oops, let's write this. The thermal efficiency, which is the net work divided by the heat input, will also increase, because what we have here is that the net work, let's put in this way, what we have here is that the net work increases while the heat input remains constant. Okay, so what is happening is that the heat input remain constant, but the network increases, and therefore the thermal efficiency also increases, just using this steam injection process. Okay, and that's the final answer. Thanks for